Now that the mesh stream is cleaned, we're ready to move on to stabilization. Successfully configuring stabilization can be an iterative process. In this section of the tutorial, we'll go through several tests to find the best stabilization settings for our clip, and then apply them to the entire clip. Stabilization is one of the driving factors to efficient compression of volumetric video. Using a feature called non-rigid deformation, a sequence of frames with unique meshes is divided into stabilized segments, where all of the frames in a given segment share a single mesh topology. Each stabilized segment uses a single frame as a source pose or keyframe, which is deformed to match the surfaces of the other poses in that segment. In this tutorial, we'll use stabilization and compression to greatly reduce the amount of data required to playback our volumetric performance. Additionally, stabilization allows artists to reduce their workload for editing tasks by providing one consistent topology and UV layout per segment. Now, let's add a stabilization stage to our track. Expanding the parameters, you'll see a list of values and toggles you can configure. There are a number of parameters provided for precise control of the stabilization process. These include sample radius factor. The stabilization process groups clusters of vertices along the surface in influence regions, where each region has a node that makes deformations between frames. The sample radius factor indirectly sets the size for these clusters. A lower setting will create smaller clusters that capture more detailed movements. A higher value will create bigger clusters, good for preserving larger volumes. Smaller values generate more nodes and will take more time to process. For a typical volumetric capture between 10,000 and 20,000 polygons, we recommend starting with a value between 6 and 15. Segment max error is used for the dynamic segmentation step, where the stabilized process builds the longest possible stabilized segments. If the correspondence error between the stabilization of a pose and the original frame is greater than this maximum, it's split into another segment. To compute the correspondence error, HoloEdit measures the difference between each point on the source mesh and its closest point on the output mesh. The furthest distance that exists is the correspondence error. The default value of 0.085 is a good starting place. If you find you have long segments but issues with the fidelity of your mesh, try dropping the value. Match distance limit. A process called point-to-point correspondence drives many parts of the stabilization process. Point-to-point correspondence produces a pair made up of one vertex on the source pose and the most similar vertex on the target pose. Match distance limit sets a hard limit on how far apart the two vertices in a pair can be. The default value of 0.119 is appropriate for a capture with a lot of motion. For a mesh scaled at real-world scale with carry frame disabled, reasonable values are between 0.07 and 0.15. The match cosine limit setting determines the maximum cosine of the angle between the surface normals of corresponding vertices in a pair, or the minimum similarity of the surface normals of corresponding vertices. Higher values mean less acceptable distance, where 1 is 0 degrees and 0 is 90 degrees. Like match distance limit, this setting can be especially important during motion. Generally, reasonable values are between 0.5 and 0.9. Alpha rigid. The alpha rigid controls the rigidity of each chunk of the mesh. Higher rigidity values can help better capture broad changes in pose between frames. Rigidity progressively relaxes during the stabilization process, so surface details may not vary significantly when this setting is tweaked. Generally, the recommended value of 100 should work for most cases. Alpha smooth. Alpha smooth weights how important it is that a given portion of the mesh moves similarly to its neighboring pieces. Smoothness captures the idea that connected elements tend to move like their neighbors. You should relax this value if there are small, local deformations in the surface over the course of the motion. Like alpha rigid, this value progressively relaxes, so surface details may not vary significantly when this setting is tweaked. Generally, reasonable values are between 10 and 100, but values at 200 or more may be appropriate for captures with a lot of cloth or soft surfaces, such as our example clip. Alpha point. The alpha point parameter determines how aggressively points on the source mesh are positioned to match their pair neighbor on the target mesh. Higher settings prioritize closer proximity between vertices in a pair. The alpha plane. The alpha plane parameter determines how aggressively points on the source mesh are conformed to the target surface's orientation. This helps preserve continuity of the result surface and prevents surface noise and stray vertices. Merge vertices. Merge vertices takes any overlapping vertices and wields them together. We'll have this on while running our stabilization. Due to the variety of performances and materials that can be captured with volumetric video, there is no one-size-fits-all configuration for stabilization. Some trial and error is required for the stabilization process to achieve the optimal results for a given clip. There are a few different qualities which make good stabilization results. The number of segments, where fewer segments means more compression and easier editing, the smoothness of motion and similarity of pose, and the preservation of surface angle and position on each frame, which is necessary to avoid texture artifacts on the final clip. Depending on your clip and production goals, it may be necessary to prioritize different results. This is a very challenging clip with complex motion and a lot of mesh differences from frame to frame, so we might not be able to get the segment count down very low. Even with many segments, it's possible to achieve great compression, so we'll focus on finding the right settings for preserving the pose and surface details. A good practice to help speed up your workflow is to test out different settings on a small portion of the clip. Find a portion of the clip that will represent the most common motions in the performance and use it to test various settings. If your actor is high energy, you'll want to pick a frame range with plenty of movement, or if your actor is mostly idle, you can select a range where they are at rest. For many captures, you may want to pick a few different portions to test settings for each major type of movement in the performance. In the next video, we'll look at running some tests on our clip.